The congruent supplements theorem states if two angles are supplementary to the same angle, or two congruent angles, then they are congruent. So look at 1 and 2. Those would be supplementary because they add up to be 180 or create a straight line if you butt them up together. And then 2 and 3, they're also supplementary. So if that's the case, if 1 and 2 are supplementary and 2 and 3 are supplementary, I can just kind of leave that 2 out and know that 1 and 3 would have to be congruent. With the congruent complements theorem, it's very similar. If two angles are complementary to the same angle or two congruent angles, then they're congruent. If 4 and 5 are complementary, meaning they add up to be 90, and 6 and 5 are complementary, then we can know that 4 and 6 has to be the same size and that they would be congruent. So let's make a flowchart proof of the supplementary theorem here. We're given that 1 and 2 are supplementary and 3 and 2 are supplementary. Okay, so supplementary means they equal 180 degrees. We want to prove that 1 and 3 are congruent. We're going to do a flow chart proof on this one. We're going to actually take the givens and separate them. So the first one given, and remember you write the reason up under the box, and the second one is given. Since we are able to say they're supplementary, we need to come back behind that next and point to the fact that that means they equal 180. So angle 1 and angle 2 added equal 180, and that would be our definition of supplementary angles. So definition of supplementary angles. Same thing with this one, definition of supplementary angles. The two pieces of information right there can be drawn together and pointed out to the fact that the measure of 1 and 2 would have to equal the measure of angle 3 and 2. It's kind of like marking those 180s out. Do you remember that that would be the transitive property? The transitive property of equality. We got the equal sign there, so this is the transitive property of equality. Now, since I'm able to say that, I can go ahead and say that the measure of angle 1 equals the measure of angle 3, and all I've done here is just subtract the measure of angle 2 from the left and the right side. If I subtracted the measure of angle 2, they would cancel out and I'd be left with the measure of angle 1 equals the measure of angle 3. So that's my subtraction property of equality. And anytime I say that they're equal to each other, I can back it up and say, well, that means that the angles are congruent, which is exactly what I wanted to prove. Angle 1 is congruent to angle 3, and the reason I can say that is simply the definition of congruent angles.